Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, and good evening. Thank you for this opportunity for me to present our paper titled Long Short-Term Memory Based Encoder-Decoder with Attention Mechanism Model for Question Generation. Brought by me uh, within my team, Dr. Dina Fitria Murad, Dr. Bambang Wijanarko, myself, and Sylvia Ayunda Murad. And this one is presented for Journal of ICIC Express Letters. So what we have today, we have the background, methodology, discussion and result, conclusion, and finally references. So for the background, digital transformation in education has an impact of revolutionary. On impact revolutionary trends in the development of learning methods and media. The dynamics of educational change that leads to improving the quality of teaching makes the online learning system a strategical important choices because online learning can bring education closer to students. The quality education is often based on product assurance and learning evaluation processes, including online learning. There are fundamental differences between the evaluation system in online learning and face-to-face learning. For example, the evaluation location, evaluation time, evaluation mechanism, and participants. This difference resulted in the need for evaluation materials in the form of questions used in the two learning methods. The online learning models applied at different times and places process a challenge in providing various questions to evaluate quality learning. Multiple questions are needed uh, in the learning process and in evaluating learning to develop a broader cognitive perspective. The main problem in this research is how to create a question generation model to support online learning. Several question generation models have been carried out using a machine learning approach, where the model is trained with pairs of questions and answers extracted from a sentence. The questions generated from these methods can be categorized as shallow questions that ask about facts, yeah, or circumstances or questions that can be answered briefly. When mapping in taxonomy blooms, these questions are not at the level of remembering and understanding. Meanwhile, a question generation model has not been found that generate questions that require answer based on questions. Bloom's taxonomy level is at the application, analysis, evaluate, and create groups. Research opportunities in the field of question generations are still open, especially for mapping uh, answers to questions, extracting factual statements, and resolving ambiguities from the document content. This opportunity becomes motivation in taking research opportunities and to find automatic questions generation, especially in online learning. The primary purpose of this research is to produce a question generation model for learning evaluation purposes. Question generation can generate a variety of learning questions that are classified into the 6 levels of Bloom's taxonomy. Question generation built on an encoder-decoder using short-term, long-term memory LSTM cells. This research was conducted by adapting machine translation techniques in the natural programming language NLP. Learning evaluation is part of the learning cycle or universal education system. Question generation contributes to supporting the availability of evaluation materials in the form of questions for the learning evaluation process. Question generation could generate various questions that have a certain level of complexity. And problem statement and preliminaries, yeah. Question generation is a system that automatically generates several questions from various inputs such as text, database, or semantic representation. Almost the exact definition is given by uh, reference, which defines question generation as a system that functions to generate rational questions with input in the form of structured data such as databases or structured data such as text. From the two differentiation definition above, it can be concluded that questions generation system is a system that can generate many questions related to an input sentence. The input for question generation can be extended to one or more sentences, paragraphs, or semantic maps. And this one, which examines several journal articles that are that the evaluation methodology in automated questions generation was classified into several categories. According to input categories, 1, 2, based on dataset, and 3, algorithm used. Challenge in question generation research are still open, including mapping. Yeah, number 1, mapping answer the questions. 2, accepting factual statements. 3, resolving context ambiguity. And 4, increasing the utility of question generation tools. More profound questions and other genres. And 6, automatic evaluation metric and use of language other than English. Then this generation question, we have the formula like this. And for encoder, we have formula like this one in the yellow one. And attention-based decoder is for the formula is in the red one. And how the way we work, we use the methodology of this one. Yeah, the research framework in this figure is structured to obtain research result and a method to answer research problems. According to the research objectives, the research question formulation consists of three critical parts to solve the main problem. The three research questions proposed for the preparation of the question generations design include the following processes. 1. Key phrase identification. 2. Question generation based on Bloom's taxonomy. And 3. Question generation modeling with a machine learning approach. And this is our discussion and result. For main result, yeah, as an important goal when presenting result is to clearly indicate new or unpublished result while appropriately citing previously published result. The discussion section aims to explain the result and show how to answer the research question posed in the introduction. This discussion is generally carried out in stages. 1. Summarizing the result. 2. Discussing whether the results are expected or unexpected. 3. Comparing the result with previous work. 4. Interpreting and explaining the result by comparing them to theories or models and hypotheses. The discussion section reverses in the introduction format, moving from the specific, the result in this work, to the general, how this result demonstrates general principles that can be applied more broadly. Problems or shortcomings encountered during the work should also be discussed, especially if they may affect how the results are interpreted. And for the discussion one is identifying key phrases. Yeah, key phrases identification is carried out to find context information hidden in semi-unstructured documents after going through the tokenization process as part of speech tagging or post-tag. The post-tag tagging process for key phrases identifies whether the phrase is a non-phrase and adjective in level 1 in figure inside figure. The assumptions used are noun phrase NN in general has a unique meaning or has a clear meaning. Adjective JJ of a noun phrase around it. After all, the words in the sentence have a heading tagger. Then this heading tag is used to identify phrase, key phrase, and context search, which is The center of the semantic meaning of a sentence or paragraph is carried out based on one or more words in the sentence. A set of words that become the context of a sentence is semantically interpreted as an object of or type of noun or noun phrase. And the second main discussion is output of Bloom's taxonomy based question generation. The questions generates from process of making question based on Bloom's taxonomy with output from 778 phrases pairs and 204 templates are 93,602 question. Yeah, sample will be shown in the table 2 and referred to the level 2 in figure 1. Bloom's taxonomy level of each question can be identified from the verbs used, although with different variation, including recognition in presence of contact phrase in the questions. An experiment using the collab Google Cloud to generate all questions took no less than 180 minutes. In general, the resulting questions can be understood in context, although there are some whose semantic meaning is still fake, so it needs to be redesigned with different techniques such as machine learning. The significant test study and evaluation of question with context and without context are presented qualitatively and quantitatively using BLEU and Cohen's Kappa measurement matrix based on expert assessment in the field of software engineering. The resulting training model is then tested. Okay, like this, yeah, table 1. So the resulting training model is then tested, yeah, with unlabeled data, X phrase 1J and phrase 2J is BTJ to predict YJ. Each generated questions has a different Bloom's taxonomy level from level knowledge, understanding, application, analysis, evaluation, and finally create. Question codes are given to make it easier to identify the classification of questions. For example, COM-S, which means the questions are at the level of understanding with variance C. The resulting questions can be a questions that require a descriptive answer or a comment so that the answer is an action that must be taken according to the context of the questions. This question generation can predict questions in two types, namely questions with context and questions without context. This depends on the input key phrases given in table 2. If the input given is a key phrase in the form of phrase only, then question generation will generate the questions without context. Whereas if the key phrase is given consisting of context and phrase, then the predicted question will have context. Next is performance of questions generation. The questions template dataset consisting of 93,602 parts of questions and key phrases. Bloom's taxonomy were used as training data and test data with a composition of 80-20%. The training process works using epoch 50 using the tan activation function and the sigmoid function for 5 trials each, observing the loss function. The illustrations on the loss function generated by space categorical cross-Santofri from TensorFlow hard works better on attention with the sigmoid activation function, which is an average value of 1.111 and epoch 4 to epoch 50. Shows a loss value between 0.001 to 0.003, which means the difference in the predictions based on training and testing is very low. The difference in the result of using the tan and sigmoid activation function also impacts the attention weight shown in the correlation between key phrases and what's used in question generated from a question generation engine and refer to level 3 in figure 1. Yeah. And to provide the difference between the average loss function using GRU cells and LSTM cells with Sigmund activation function, shown in figure 2, experiment with the LSTM. Yeah. Model take longer, about 6 hours for one experiment with 50 epochs, but are able to provide improvement to very good result, namely there are no error and able to generate new questions using sub-key phrases. The model training process use pairs of question sentences according to Bloom's taxonomy and key phrases consisting of context and question variation codes. If the model is tested with a key phrase that has not been trained before, it produces decent results. And the last one is Bloom taxonomy based question performance. The question generation algorithm based on Bloom's taxonomy is designed to process input in the form of a text document of learning material totaling 683 declarative sentences into 93,602 questions belonging to 6 levels on Bloom's taxonomy. The resulting question consists of 41,196 questions using context and 52,406 without context. The questions are built using 777 key phrases in the form of unique context phrases obtained from the extraction of the same input document. Evaluation of this question qualitatively is carried out by human reviewers who have competence in the field of study according to the discussion material used as the object of the questions. The output of this qualitative evaluation process result in the tabulation of data about the suitable of the semantic relationship between words in the question candidates sentences and the number of reference sentences as their pairs. The tabulation data from the reviewer in the form of a sign with the notation 0 for sentences that are not easily understood and 1 for integrative sentences that can be understood easily and clearly. They were evaluated quantitatively using the BLEU metric and Cohen's Kappa score calculation based on tabulated data and candidate and reference sentences pairs. The selection of these two metrics is based on the state of the part of the art tools used by researchers to measure text generation performance. And table 3 shows the result of measuring BLEU and Cohen's Kappa scores obtained from 5 human reviewers on 120 candidate sentences. And this is table 3, the result of measuring BLEU and Cohen's Kappa scores obtained from 5 human reviewers on 120 candidate sentences. Yeah, and the ability is the average BLEU score obtained from question using context 0.921 looks higher than question without context 0.861. This shows that the question generation algorithm is able to generate questions using words that are similar to the questions compiled by the reviewer when making similar questions. Cohen's Kappa scores on questions using context of 0.6273 appear lower than questions without context of 0.760. However, these two scores are in a good category, which means that the reviewers have a good agreement in capturing the context of the questions. And for the LSTM, from the past from the last experiments on questions generated from the question generation model using LSTM cells, the result of the BLEU and Cohen's Kappa evaluation were obtained. As shown in table 3, BLEU's average score increased to 0.9210 and Cohen's Kappa to 0.6273. The interpretation of Cohen's Kappa value is 0.6273, shown in table 3, is included in the substantial categories according to Lenz and Koch, or good and almost excellent according to phrase error. This result indicate that the use of LSTM cells can improve the performance of the question generation models. And here we go with the conclusion. So the question generation generated in this study can accommodate learning evaluation needs that rely on 6 levels of Bloom's taxonomy. The performance of the 6 proposed question generation was tested by measuring the BLEU scores and Cohen's kappa, which involved human expert in validating the output. Thus, this question generation research becomes strategic value to support the achievement of specific learning objective or the success of education in general. What is new in this research is a mechanism to find a key phrase in a sentence. And the result of this study indicates that the encoder-decoder techniques that is processed with a good mechanism can find the context of sentence in making questions that are trained using Bloom's taxonomy-based questions. And this proves that the result can achieve competitive performance. And in this study, we have not used a recommendation system. So the questions and answers also have not adapted to the personalized needs of students. This is our limitation for now, but it will be in our next concert. And in the future work, we plan to investigate methods of extracting answers from corpus text based on machine-generated questions. We also plan to investigate the performance of the question generator model with the encoder-decoder variation to extract answers from questions. And this is our references. We cited from 15 sites. Okay, and here we come to the final slide, which is thank you. So thank you for the opportunity for us to bring our paper titled Long Short-Term Memory-Based Encoder-Decoder with Attention Mechanism Model for Question Generation. And this is present for the Journal of ICICEL. Thank you. Assalamualaikum warahmatullahi wabarakatuh.